Max, the creator of Genome Island, is participating. This TelePortal is an interdisciplinary portal. We usually learn deeply in one discipline, but many social problems related to multiple disciplines. So we don't have to hesitate to visit places we are not specialized in. And because everyone other than the creator's specialty at the place is equally amateur. And visualized 3D world may help us to understand. But visual museums are not always easy to understand for us. One of the reasons is that both creators and visitors are not developing literacy in the language of image so well. To say in detail, let's go to Genome Island. Please follow me. This is Genome Island teleport portals. So please touch Genome Island board. So you can see short explanation and teleport destination list. So one arrival point. Please click arrival point. Genome Island is one of the most well-designed museums in Second Life and also highly specialized and difficult to understand. So it is reckless for me, an amateur, to guide you here. So here is near the center of this island. From here, we can see all of the exhibit places in Genome Island. Like this. So it's like Disneyland Center Square surrounded Fantasyland, Tomorrowland, Adventureland, Frontierland. This way is Genome Tower, molecular genetics, and terrace, including some gallery and bioinformation kitchen, and Abbey of Mendel's Law. And this way is Genome Pool. The location of the arrival point is very important to allow visitors to navigate well. Real-life museums are surrounded by walls and viewing course is defined. And visitors enter from the entrance and go through and out from the exit without thinking of floor arrangement. On the other hand, Second Life Museum has no fence and anyone can arrive at any point and can also move to any direction. In addition, the view angle inside the PC screen is so narrow and it's difficult to maintain to sense of direction. Because of them, it is difficult to guide visitors well at virtual museums. So I said so the location of the arrival point is very important. From the standpoint of image language, this here should be more prominent or outstanding because visitors need to come back here repeatedly to move to the next exhibit. So, for example, a big DNA model can be good landmark, but aesthetically, I don't know if it is best. So, northwest is the Tower of Molecular Genetics, and opposite side, ABI, Mendelian inheritance patterns. Both are prominent. It is important to navigate visitors. So please see this panel, Genome Island, a user guide. So please touch. Look at the bottom right of your screen. So now you can see go to page. So please click. This Word document will open. This user's guide is for the teacher's guide. You can open these contents. For example, Control plus click the tower, then tower at Genome, and more detailed contents, genome and DNA, or genome organization, human genome. So, Control plus click. Then more detailed information. So this user's guide is 161 pages in total. So this is more than Genome Island in a sense, or complements Genome Island. So text language is really powerful for systematic transfer of mass knowledge. But whether one-way passing learning is effective is another matter. Let's see how these 161 pages of information are arranged in the 3D space of Genome Island. So, and please look at the bottom right of your screen. Please open all of icon. So you also get the illustrated guide of Genome Island. This is very convenient for landmarks. So please refer when you lost your destination. So open your inventory and click recent tab. So there is new note card. There is illustrated guide to Genome Island. And click list of icons. So Genome Island T-shirts, please accept if you like. So please be careful for bottom right of your screen. And so you get some things when you don't know. And first destination, please follow me. Go to Abi from now. So I said before, past tour, left-hand rules. So English is written from left to right. So panels may be also arranged from left to right. So it is left hand on the wall in maze. So left hand rule. Walk with the left hand on the wall in maze. And if the museum intended to give experiences only, image language is powerful. But if the museum also intended to give systematic knowledge, it's impossible without usual language, text, and speech. So in this abbey, most basic information displayed by slideshow. So touch, then uh, so you can see most important basic information. And come here. So this is uh, slideshow three, and click and click and click and click. So this says in a monohybrid case, red is the dominant phenotype. Then fluorescence ratio equals 3 red to 1 white. Please remember this. And the opposite side, this side is show the hybrid cases. And please see slideshow 7. Then click. In a dihybrid case, red and tall is dominant. Then 9 tall red and 3 short red and 3 tall white and 1 short white. So please remember this. Then please come here and go through wall and come to greenhouse. So this is monohybrid cross. Yellow peas and green peas. Yellow is dominant, so first hybrid is yellow. Then click yellow peas. Then you can see second generation of peas. There is 60 peas. And so theory says so 3 to 1 ratio. So green peas should be 4. But now you can see 1, 2, 3, 4, 5, 6 P. So touch this again. Now only 4 green peas. This is same as theory. And touch again. So there 1, 2, 3, 4, 5, 6. And touch again. 4. And touch again. Only 2. And touch again 4. Touch again 3. So not always 4, but so average is maybe 4. 4. So maybe there is a single player crystal note card. And you can see Excel file. Like this. So please you may copy one, two, three, four. And paste this Excel file. Okay. And count yellow or green. And input yellow or 3. So each case is not 3 to 1, but average maybe approach to 3 to 1. So don't forget to open bottom right icon. And next, please come here. So this is the hybrid case. So tall red flower is dominant phenotype. So red tall flower and white short flower. Then first generation is all red tall uh, flowers because red and the tall is dominant uh, phenotype. Then please see second generation. Theory says red tall flower should be 9 and white short flower should be 1. But 1, 2, 3, 4, 5, 6, 7, 8 flower and there is no short of white. And click again. Then now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tall red and 1 white. And click again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 red tall and no white. And click again. So 1, 2, 3, 4, 5, 6, 7, 8 and 1 short white. So click this board so you accept a note card and maybe short later you will get another Excel file. Go to page. Okay. So you copy and paste nearby chat. And paste today's case and count tall red or tall white or short red and short white. So race is maybe approach to theory 9 to 3 to 3 to 1. So second life random simulation teaches average approaches the theory as we repeated it. Then next, please follow me. We go to the tower. So back to arrival point and go through. Then we'll come to. I said for giving systematic knowledge, it's impossible without usual language, text language. In real-life museums, explanation panels are hanging on a wall at each exhibit. Visitors are interested in one of exhibit. They will approach it, then find the detailed information. We do the same thing in Second Life. Lots of high-resolution textures consume CPU power. And text display by textures is very troublesome for museum creators. So in world building using basic streams in Second Life is very powerful and comfortable, but in word editing text tools are poor. And for short messages, floating text and whispering in nearby chat can be seen among people and easy to edit. But for long explanation, Genome Island mainly relies upon notepad givers and web page loaders or file loaders, but they are only visible to those who touch givers or loaders. Uh, It means a lot of information is hidden behind the givers and the loaders. So visitors are required to take positive action to digging information. Please look at this bench. This exhibit shows the first demonstration that DNA might carry heritable genetic information. Yes. Then, so several note cards are obtained from signboard here, and well, here. Let's go to pages, and click test tube. Also, no, not card. And click mouse. So not card. So each test tube and mouse, uh, they give not card and die live. And from cage, not card. So an information is divided and arranged in 3D space so that each information is associated and structured. So you will be surprised how this tower contains incredible amount of knowledge from history of molecular genetics, DNA analysis methods, and human genome to evolution of life. So please come. So this is also history of genome and about protein. So please look this teleporter to ribosome row. Please click and teleport to ribosome row. Okay. So this is exhibit about the protein synthesis translation of the genetic code. So maybe start from here. 1 and 2, 3. So this is not left hand, right to left. So I may suggest opposite arrangement is better. And this is very interesting game, protein synthesis game. Ask many students, and many students become transferred RNA. And they choose one of amino acid and take and set this tube or trough. Then synthesis begins.
If the ribosome row is arranged right to left so that the so that the process ends when you get to this spot. But I could actually rearrange the whole thing if that would make more sense. But in this game, I guess it's really not a game in the sense of competition, but it's a demonstration of how translation works, how protein synthesis works. And in this case, the student is playing the role of the transfer RNA because the transfer RNA brings amino acid to the ribosome. There are 3 binding sites in the ribosome. And the transfer RNAs actually move from point to point as they move through the ribosome, carrying their amino acids. And so I have the genetic code is up there, so the students can look at the codon, the 3 bases that is above the first chair, and that says AGU. And so if you look at the genetic code, then AGU is AGT up here. So we need to find that. So here's A, and here's G over here on the right. So if we look for AGT, we find that the amino acid that matches is serine, or S. And so we look here and we find serine and we pick it up. And let's see.
Oh,
all right. So here you've picked up the amino acid and you have it in your inventory. So I look at my inventory under objects, and here's serine. So then I drop that into the trough.
Oh, okay.
Okay. So it goes in there, and then it will roll down the hill. This is phantom, so it can roll right through that. But as you drop the amino acids into the trough, they roll down the hill. Well, it's not rolling down, but they roll down the hill, and then that lines them up in order that they would be arranged in the protein. It's way more complicated than it should be, though.
Roll down.
Yeah, why it's not rolling.
Not rolling. Okay. So please demonstration next time. Please come here. So this exhibit is most difficult how to use it. And here is teleporter to cell platform. So please teleport to the cell platform, and we will see real ribosome and protein process, where the process are working in a cell. So please come here. So teleport to eukaryotic cell. So, and touch plasma membranes. So you can enter. And so please touch blue pores. Right click and select nucleus. So we can enter nucleus. Please share the screen. We enter plasma membranes. Membranes is envelope of an eukaryotic cell. And so yellow Yellow is so famous mitochondria is energy producing organelles. So click so you can see detailed information. And the centuriolus is so orange here. This is quick and so maybe okay. So centuriolus is organizing center for the microtubes of the mitotic spindle. And here brown Golgi complex is difficult to say, but so relating processing proteins. And so in a nucleus, green, including double membranes and chromatin and nucleolus. So what is chromatin? Means including chromosome when they are working. And red is ribosome manufacturing center. So we saw ribosome coffee cafe game. So ribosome is working from here. And so maybe this is chromatin, chromosome, maybe so DNA or RNA. So mitochondria also have RNA, but main DNA including here. So that is all of today's tour. Thank you today.
It has been really great to to go on this tour and keep my mouth shut, and see how it's working for other people. So I really have appreciated all the work you've done, Jan,
Mm.
in putting this together and all the suggestions that you made, most of which I was able to do, but obviously I still need to fix that translation game. But
Oh,
I really have appreciated your
mm.
efforts. I really have. I enjoyed this a lot.
Thank you.